Hello dear friends, myself Jayesh and I am working with personal tutors Saket Square, Indore. Today I am going to teach you an important part of physical chemistry which is of class 12th, and it's the second chapter of your chemistry which is of physical chemistry, and it's very basic and an easy chapter. I hope you get through the chapter quite easily. Before starting my topic, once more I would like to recall you, memorize you, that myself Jayesh, working with personal tutors, Indore. Let's start without wasting our time. Our topic is solution. Now, when you say about the solution, then you have to remember it's made of two phases. Phases we also refer as the components. What I mean to say exactly is that the first phase is the solvent, to which we also say it as the medium. We'll go for the example of solvents, the various type of solvents that are usually used to make the solution. The second phase of solution is a solute. What we mean by the solute is the part or component which is being dissolved in the solvent. Let's consider an example to know about exactly that what I was saying you. Like if you speak about the water, which is H2O, then this water is a solvent. When we speak about solute, we could take the solutes like glucose, which is C6H12O6. Now when you combine these two components, you get the glucose solution, or in other words, you have to dissolve this solute glucose in the solvent water. Here I would also like to inform you that water is a universal solvent. That means water has a tendency to dissolve almost each and every type of solute in it, although some exceptions could exist depending on the nature of solvent or depending on the type of hydrogen bond that a solute makes with the water, because the solubility of any solute in water is dependent on the chemical nature of solvent and solute, and secondly on the basis of fact that what is the tendency of a particular solute to make the hydrogen bond with the solvent. Higher the number of hydrogen bond a solute makes with the solvent, the higher is the solubility of particular solute in the water or any other given solvent. Now dear friends, we'll move little ahead in this chapter, in this our concerned topic, that is in solution. Here we'll define the solution scientifically, that is for a 12th class student. For 12th class student, we say or we mean that solution is such a type of mixture where the number of moles of solute are quite less than the number of moles of solvent. This NB is number of moles of solute, which is quite less for a given solution in comparison to Na. Na is the number of moles of solvent. We could relate it with the previous example of glucose solution, where glucose is our solute and water was our solvent. So for a 12th class student, we define the solution with the concept of mole concept, where NB is number of mole of solute and Na is number of mole of solvent. Further, when we move ahead in our particular topic solution, then as per NCERT syllabus of class 12th, we have to move for the next part of the solution, which is classification of solution. Now what I mean by classification is that we are talking about the types of solution. My dear students, Again, when we classify the solution, then we classify it on two bases. The first basis is on the basis of interaction between solvent and solute. I would explain you what is the meaning of interaction. The second basis is on the basis of extent of solubility of a particular solute in a particular or a given solvent. My dear students, my dear friends, kindly remember these two bases because we are going to explain it. We are going to explain them. The first basis, as you could look on the board here, it's on the basis of interaction between solvent and solute. So first we'll classify the solution on this basis, that is on the meaning of that is on the basis of interaction. I will also make you explain that what is the exact meaning of interaction. The second basis would be, as you are seeing already on the board here, that it is on the basis of extent of solubility of a particular solute in a given or a particular solvent. So let's start classifying them without taking much more time here. My dear friends, as I said you, I will explain you meaning of interaction. We are saying we are classifying the solution on the basis of interaction of solvent and solute. So interaction means the physical state. I suppose being a 12th class student, you know that what is the physical state? That's solid, liquid and gas. So our first basis to classify the solution is on the basis of this fact that what are the physical states of solvent-solute pair. According to this criteria, there are 9 types of different solutions which we can represent on the board in a tabular form. Like here you could take the physical state of solute, and here you could take the physical state of solvent. We could make one more column here for example of such type of solution. This is on the basis of interaction. Here we will have 9 type of solutions based on the interaction or the physical state of solvent solute. The first one is, it's quite easy to remember. The first one is you can take solute as solid and solvent as liquid. This is the most common type of solution. As we studied previously right now, that glucose. So glucose is a solid solute and we dissolve it in water, if you remember. So water, the physical state at room temperature is liquid. Most of the solutions are of this type. The second type of solution where we dissolve the liquid in liquid. My dear students, please you look at the pair of solvent and solute, because here solvent is liquid but solute has changed from solid to liquid. Now you are dissolving a liquid in liquid. Please remember that when you dissolve a liquid in liquid, like for example if you dissolve alcohol, that is ethanol, in water, then this is the example of this pair, because ethanol is liquid at room temperature and water is also liquid. So solvent solute both are liquid. When we are dissolving liquid in liquid, this solubility is based on the fact of the principle of like dissolves like. That is what I mean to say is, if two liquids are of similar chemical nature, say both liquids are polar or non-polar, then extent of solubility is fairly high, or we say excellent solubility or excellent miscibility. So this solubility where solvent and solute both are liquid, it's based on the principle of like dissolves like. The third type of solution based on interaction is when you dissolve a gaseous solute into a liquid solvent. My dear students, please remember that when you dissolve a gas in the given liquid, then the pressure of gas has to be subsequently quite higher, and the temperature of liquid at which you dissolve the particular gas in a liquid, the temperature has to remain constant. Pressure applied on gas must be higher. Or in other words, what I mean to say is, the solubility of gaseous solute in a liquid solvent is the Henry's law. We'll also try to recover Henry's law here to study about it. But for time being, you remember that the solubility of gas in liquid works on the principle of Henry's law. For example of gaseous solute in a liquid solvent, we have the example of aerated drinks, or what you say is a soft drink or a cold drink, where CO2 gas is dissolved in the water. Now when you dissolve CO2 gas in a water, the pressure of CO2 gas has to be increased and the temperature has to be remain constant, which is an important condition for Henry's law. For the next three type of solutions, you just need to change the solvent. That is, our solute would be solid, liquid, gas, and our solvent is going to be like this time you could take here the gaseous solvent. Similarly, you can move for the 7, 8 and the 9 type of solution. Here we take solid, liquid, again gas, and now here we have to take solid, solid and solid. For each of these we have a particular example. Like if you dissolve the solid in gas, then in that case we have a particular example. For liquid in gas we have an example, and for gases in gas we can take example of atmospheric gases, which is mixture of number of gases. For example of solid in solid, we can take the example of alloys. For example of liquid in solid, we can take the example of jellies or gels. For example of gas in solid, you could take the example of sublimate solid. Now, being a highest grade students, I suppose you know that what is sublimate solid. What are sublimate solids? Sublimate solids means that when we heat such type of solid, they directly change into gaseous state. Like we have naphthalene, we have solid iodine, we have camphor. So they are in this example. So various type of examples could be taken for each of the classes. So this makes the 9 type of solutions on the basis of interaction. Our second basis to classify the solution, if you remember, I written on the board, that is on the basis of extent of solubility of solute in a solvent. According to that concept, we have 3 type of solution. That is saturated solution. Second one is your unsaturated solutions, and the third one is your supersaturated solution. We will go for the meaning of these 3 also. Saturated solution means where the solute dissolves in the given solvent up to a maximum limit. That is, you have a maxima for solubility of solute in a particular solvent for our saturated solution. Most of the solutions are saturated solutions because for most of the solutions there is a maxima, there is a maximum limit in which a solute dissolves in a given solvent. The second type of solution, as you could look here on the board, is the unsaturated solution, where a little more solute could dissolve in comparison to saturated. That is, beyond the maxima we could dissolve a little more solute in a given solvent. And the third one is a supersaturated solution. We explain the supersaturated solution. We say that it's the solution with infinite solubility. Now what we mean by infinite solubility is, we take the example of the solubility of salts in the seawater. My dear students, you know there is not a particular limit or a maxima for the solubility of salt in the seawater. As much salt you add in the seawater, it's going to dissolve. There is no end for such solubility. So such type of solutions are the supersaturated solution. Remember one thing about supersaturated solution, that for supersaturated solutions, the amount of solvent is in very large quantity than in comparison to that of solute. So my dear friends, I suppose you liked this concept, and I also said that we'll go for the Henry's law. So Henry's law, we'll go for the Henry law before summing up our little part that we discussed today. The Henry law, as I said previously also, it's for solubility of gas in the given liquid. As per the concept of Henry's law, the amount of gas dissolved, that is, we say X by M, which is number of mole of gas dissolved. The number of mole of gas dissolved, or the amount of gas dissolved, that is X by M, is directly proportional to the pressure applied on the gas. But remember, in this process, the temperature has to be constant. Temperature must remain constant. So this is the extent of solubility of a particular gas in a given solvent, which is a liquid solvent, and the X by M, the extent of solubility of solute, the mass of solute dissolved in the given volume of gas, increases with the increase in pressure, and temperature has to remain constant. Further, we could elaborate this by the number of moles dissolved, X by M, extent of solubility, directly proportional to the pressure. When we remove the proportionality constant, then we bring here Henry's constant, that is kH. So this becomes kH into P. On the power we have 1 by N. So this is the Henry's equation. The application of Henry's law is in the various fields. It's having even a medicinal use, medicinal application, where we consider the solubility of oxygen gas in our hemoglobin present in the blood, which is liquid. We also have the example of solubility of any particular gas in a natural river bodies, in a natural water body, where oxygen gas is dissolved in the water of like rivers and etc. water bodies present on the earth. So Henry's law finds its practical applicability in different examples of our daily life that are around us. I hope, my dear friends, you like this little idea of defining the solution, considering its type, that is classification with example, and the Henry's law, which is for extent of solubility of the liquid, the gas in the liquid. My dear friends, if you like the video, then kindly subscribe it and like it, which is on the Personal Tutors YouTube, and myself Jayesh Mulchandani, working with the Personal Tutors, and I hope this little video would help you a lot to understand about this solution. We'll bring about the solution some other important aspects in our next video, like we have colligative properties, we have different units of expressing the concentration of solutions, and many more things would be there in our upcoming video. So kindly keep watching and like to subscribe, then it's really thankful to you. I would be really thankful to you on the behalf of Personal Tutors Indore. Thank you so much, dear friends, dear students.